Hey, thank you all. I know it's hard to come up with time to join a webcast like this, so I really appreciate your taking the time to come and join us today. I'm Bill Stearns, and I work with Active Countermeasures as one of the support team. Um, this is a little odd because technically I'm not a developer, and the people who really are smart enough to do this development know that I'm not a developer, and they put up with me anyways. So this is a real treat for me to be able to come up and talk a little bit about Python programming and how you can make your own sniffer. So if you haven't gotten the slides already, please download them from the ACM webcast content channel on Discord. Once you've gotten those, you'll also need a copy of the Python script we're working with today, and also a set of packets. And that file is in the link on this page. So you can either download it from the command line using the tool wget, or you can just download it with a browser, bring it down to your system. This means that as you're testing your customized script, you have a set of packets that you can read from without having to worry about permission to read off a network interface or any other issues that might show up with that reading packets live. So back to what's the point of today? We've got a slew of tools that will read packets, give you summaries of what's in those packets, show you particular fields, allow you to do all kinds of tasks. I think if I sat down for a couple of days, I could come up with 100 different programs that all know how to read packets and analyze them in some way. The reason for today's webcast is that you need the ability to customize what you see. There may be times when none of those tools do what you want. And so the question is, could I write my own? And obviously the answer is yes. What I've done is made up a tool called sniffer underscore template.py. We're going to spend most of the class talking about that. And I'm going to show you how that works. The goal of this script is to do all of the annoying stuff that nobody should have to do anymore, leaving you to make whatever custom changes that you want to the code. So this really is it takes care of about 80% of the work of writing custom packet sniffer. The last 20% is up to you, and you can do whatever specific task you need. We'll have time to actually look at this live. I'll do that as part of the middle of the webcast. And then if you've got questions at the end, I would love to hear them. So how does this work? Python is a programming language, just like C or JavaScript or Rust or Perl or Ruby or any of the others. Python by itself doesn't know what a packet is. It doesn't know how to look down on a network wire and pull up a packet and strip it apart into its different components and let you build packets from scratch. That feature is provided by a library called Scapy, Scapy. This was written, this has been in development for easily 10 years. And the tool has grown from a very simple one that knows how to look at very basic IP and TCP headers into a library that really understands a hefty portion of what goes across the internet. So Scapy has two tasks. The first is to take the packets on the wire and break them up into individual components so you can see them. The second is it allows you to create packets by hand. So if you're trying a particular attack, and this attack says you've got to have this value in this field, and you've got to send it at your target system, and you need to make these other changes to these other fields, you can actually construct one by hand and send it off. We won't be covering that today. It's not really part of our mandate, but we will be talking about how Scapy has the ability to show you what's inside a packet. This library and the script that we're going to be working with today can read packets either directly off of a network interface, so you can look at what's coming in and out of your system live, And like most packet capture tools, it can also read out of a file. So there was a point in 2001 where one of my colleagues captured an hour's worth of packets and saved them to a file. That file is that collection of packets off of a test network, and you can download it right now from the ACM webcast content channel and have that packet. You can analyze it in whatever you want. Um, so once you've downloaded that, you'll want to check that you can actually work with it. So I want to show you real quick. I'm not going to get quite to the entire script yet, but let's show you how that works. I am going to switch away from live video, from the slides, I think. Aha, sorry, it was just taking a minute. Thank you for your patience. Aha, hold on a second. Sorry about that. Let me go and this is the problem of having multiple displays and not always keeping track of where everything is. Thank you for your patience. Here we go. Great. So what I'm going to do is take a look at that program, and I'm going to show you what happens when you run this program by simply stopping and showing a single packet. So let's come down here, and I'm going to edit this script, and I'm going to show how a packet looks, and then I'm going to stop as soon as I've shown a single packet. Now, let's take this script and I'm going to run it. Let's see if this works. Okay. So I asked it to read the first packet out of the file, and I asked it to show everything that it found. And what it did was it broke the packet up into different headers. This is the Ethernet header where two Ethernet cards are talking to each other on the wire. This is the IP header where a particular machine at IP address 192.168.99.52 is sending out a broadcast, which starts with IP address 239. Here's the UDP header, which says that this is going to port UPnP discovery. And here is the payload of that packet. So remember, Python doesn't know about packets, but Scapy does. So the Scapy program got a single packet off the wire, and it broke it up into these individual headers. And inside those headers, it found these fields. And this is the basic way that Scapy starts off by showing you inside the Ethernet header, I have a field called dest. And inside the IP header, I've got a field called version. And inside the IP header, I have a field called flags. And inside the IP header, I have a field called proto, and so on. So this is the quick and easy way where if you don't remember what a field looks like, you can simply say, hey, show it to me. And now you can go back to your code and say, oh, that's right. The field I was interested was proto. That tells me whether it's TCP or UDP, for example. All right. Now, let's see if I still have my slides. Just a moment, please. That is not it. Okay, just a moment. Thank you very much. Okay. So I'm just going to leave this up here for the moment as is. I'm not going to switch over because if I do it full screen, then it keeps changing tabs on me. All right. So we showed how a packet is read by Scapy and analyzed. The packet capture file that I talked about, you can get it from this URL, https://t-level1.s3.amazonaws.com/PySensor.pcap. And remember, these are in the slides. If you can't type as fast as I can read, pull that file down with the wget tool or just load it up into a web browser. The file comes down to your system, and now you can follow along with the test that we'll do in just a few minutes. Okay. If you want to make sure that you can read that file and analyze it, the program tcpdump is very straightforward. It allows you to read the file, shows you a one-line per packet summary. And the commands to install tcpdump and do that tests are right on your screen. Okay, Scapy is a little bit odd. It doesn't come with the Python programming language, so you have to install it. If you have the Python library tool called pip, you can install it by running sudo pip3 install Scapy. And that will go out and pull down the library, load it up for your version of Python. It's ready to go. If you don't have Linux, or if you don't have pip, more importantly, you'll need to go and install it a different way. And there are a number of ways to do it. So rather than trying to cover them all, what I'd like to suggest is you go to scapy.net and click on downloads. They'll have a couple of different ways to install Scapy, and sometimes it's part of your operating system. It usually isn't. It's not usually included with your OS, but if it is, that's great. As I continue talking, if you have any problems with installing Scapy, you can put them over into chat. We have a couple of people here who've worked with Python in the past, and I think as a team, we should be able to kind of work out whether there are any problems, work out any problems you may come across. I want to point out something real quick about the editor that I'll be using today. It's not a big deal, but I just wanted to point out that sometimes editors just show you each of the characters you've typed, and that's it. That's their job, and they're done. If your editor knows how to do syntax highlighting, like mine, what you're going to find is it's going to color things differently depending on what this is for your specific programming language. I'm using an editor called Midnight Commander Editor, or MC Edit. It's part of the MC package. So if you install MC with your package manager for your operating system, this will come along with it. It's a side plus. And it color codes everything based on what it is. So it knows that these are all comments, and it highlights them that way. It knows that these are some variables that are getting value, so it highlights them. These are import statements. They're color coded differently. When I get down into individual functions, they start off with the keyword def, and then the name of the function, and so variables. This doesn't change the task of programming, but it makes it easy to catch silly mistakes. So let's say I'm coming across and I am writing this code and I forget to include one of the quotes. Watch what happens to my screen when I save the version without that second necessary quote. You see how everything below changed color and the colors start turning wrong? Well, this has saved my butt a number of times because now I can see that I've got a mistake in how the quotes are paired up, or the parentheses, or something else. It's really handy. It's called syntax highlighting. Wikipedia covers it very well. Most editors have some ability to do this, but not all. And I've included a link in the slides to a Wikipedia page that talks about the ones that do have the ability to do syntax highlighting. It's just a side note. It's not a core part of the presentation. Okay. So let's get back to sniffertemplate.py. What I was aiming to do with this project was to take care of all of the garbage that has to be done in writing a sniffer so that you could focus on just how do I get the information I need out of a packet and display it in a form that I want. So when you pull this file down and take a look yourself, there are a lot of pieces in here that really you don't need to touch. Everything at the top is all, I call it boilerplate. It has to be done no matter what task you're accomplishing. So with the exception of this block up here that we're going to use in just a few minutes to decide which example we're going to work with, all of these entries down here are just tasks that need to get done, but you don't have to write yourself. In fact, you don't even care about what's in here until you get down to a function called process packet. And what I'd like you to encourage you to think about is the process packet function is handed one packet, nothing else. You get to tear that packet apart, pull values out of it, do tests on it, see it if you just want to take a look. But all that you're going to do happens inside process packet, and you can ignore basically everything else in this script. So that's why I'm saying that you're about 80% of the work is already done for you. I'm going to take those sample lines back out that we use to just display the code. And now we're going to kind of take a look at what we're going to do next. Hold on a second. If you don't have a copy of sniffertemplate.py, that's in ACM webcast content, and the exact same file is also available up on GitHub. The URL in the slides will take you directly to that file, and you can download it from there. No matter which way you get, the file should come down to your system, and if you want to run the SHA-256 sum program to make sure it hasn't been modified, this is the checksum that you should get when you pull that file down, either way. So that process packet function is now going to pull out the different parts of the packet. And what I've done at the top is done a couple of convenience things. First of all, most of the time you do care about what's the source IP of the packet and the destination IP of the packet. So right off the bat, I've said, if this packet has an IP version 4 layer, which is this value right here, I'm saying if it has an IP header at all, I would like to go into that IP header and I would like to extract the source field. And I'm going to assign that to a variable called source IP. Now, further on down in this script, you can access that value by looking at the variable source IP. And we'll see that just a little bit lower. Same with the destination IP. I'm going to grab the packet, which is P. I'm going to go look at the IP layer, and I'm going to look at the DST field to get the destination IP address. So now let's say you want to test to see if the destination IP address starts with 127. Your check could be, and I'm just going to write this in here, you don't have to follow along, if dest underscore IP dot starts with quote 127 dot print loopback address in destination. And that is not valid for a packet that's being sent on an Ethernet wire. So this is the way that you can work with these variables. You take the value that's already been assigned, the destination IP address, you check to see if it has it's equal to some value or it starts with some string, and then you can print out a warning to the end end user or save it in a database or whatever task you want to do. So you've already got the destination IP address and the source IP stored. We get the payload of the packet. I pull that out if it exists. And we actually have the ports. Yes, down here. If it's a TCP port, then I pull out the source and destination port. If it's a UDP port, I pull out the source and destination port. And if it's an ICMP packet, I pull out the type and code and assign them to source and destination port. Even though they're not technically ports, that's the usual place you'll find them inside this, inside most sniffers. Okay. Now, I won't go through all of this, but I do want to give you a live demo of how this works. So what I'd like to do is start off with an example called protocol count. I'm going to take these packets in this file, and I'm going to look at what protocols are most common. Let's save that, and I'm going to run sniffer template.py, and I'm going to read pysensor.pcap. These are the two files that you've got on your system. Note that you may need to run it as Python 3 sniffer template.py -r pysensor.pcap. Depends on your system and how your version of Python is set up. Let's take a look at what we get back. It's going to read all, I think it was 38,000 files, and it's going to hand me back a summary of what's the most common protocol. We'll give it just a moment here because it's got a lot of chewing to do. That's how demos always work. There we go. And so UDP is the most common in this particular type of packet capture file. There are 21,000 plus UDP packets. There are 9,000 TCP packets, 1,900 ICMP packets, and so on. How do we do that? Let's take a look because it's valuable to see how we did this. So I made a variable up here called proto counts. And this format might look a little bit odd, but basically I'm setting up an empty dictionary that remembers each of the protocols and how many times each of them were seen. Now, if we wanted to see the protocol count example, which is what we have by default. Actually, that's further up on the screen. Sorry. I'll show you where that is. I'm going way up to the top. And this is about 30 lines down. There's a line says code _ example equals protocol count. All right. That's the example that we're going to work with. So way down near the bottom, if you search for protocol _ count, I have a task that says, actually, I'll do my own search. Here we go. Protocol _ count. We already have that. Here we go. So I've remembered how many times these packets have showed up here. This is the functional part of the script. It says proto counts sub my protocol, which is ICMP, or TCP, or UDP, plus equals 1. It just means increment it by 1. So every time we see an ICMP packet, the protocol counts for ICMP go up by 1. Every time we see a TCP packet, the protocol count for TCP goes up by 1. So all we're doing is remembering that. And then down here near the bottom, I actually print out those values where I have in the left-hand column the protocol name, and in the second column I have the count. And that's how we had the example that we saw a moment ago where the left-hand column shows the protocol name and the right-hand column shows the count. This is very basic. But what I want to show you is there are very few lines of code that you need to modify to do many of the tasks. Okay? All right. So what choices do I have when I found a packet that's interesting? Well, in the example we just did, all I said was, let me save that. Let me save some statistics on which protocols were common. I didn't actually show anything for every single packet, but I can print something to the screen, maybe a one line per packet summary, maybe an exclamation point if it's a reset packet, maybe an underscore if it's a common packet, and an X if it's uncommon. Whatever I want to print to the screen, I can. If I want to save something to a database, MySQL, SQLite, whatever I want, whatever Python supports, I might save that packet off later. And I can even write those packets to another packet capture file. So I can flag a packet as interesting and say, if it's interesting, save it off to this other file because I might want to look at those by hand later. Okay. So with each packet that you deal with, we're going to look at the individual headers, grab out the fields that are important to us. And just in case you're wondering where I'm scrolling, this is the process packet function. So search down for process packet. And then if you come down here, I've pulled out what I think are some interesting values. And I have pulled out the source port and destination port. But you can say, hey, I'm trying to work with TCP flags here. Let me pull out all the TCP flags. And so you come up to where this block looks at TCP headers. And now you can say, I want to also get the TCP flags. And here's how you would do that. I want the string of P sub TCP. That means look in the TCP header of this packet. And I want the flags field. And I want to assign that to a variable called TCP flags, because maybe I'm looking at the packets that have reset and fin both turned on, or synfin packets, which are both illegal. You shouldn't have that combination. So now that I have this TCP flags variable, then I can test for different values against it. The obvious question is, well, Bill, how did you know it was called flags? And that comes from the example that we saw a few minutes ago, where I ran this script and I looked at a single packet. Oh, actually, that didn't work because I need to get a TCP packet. So let's say I don't know what this field should be. And so I'm saying, well, I need to go and have the script tell me what the name of that field is. We go back to our original trick. I say p.show, and then I say sys.exit, saying I want to immediately stop the script so that I can look at that output and decide what field I need to work with. Okay. So let's run this, and as soon as we get to a TCP packet, we're going to see how a TCP packet looks. I run the sniffer that I'm working on, reading in that pysensor.pcap, and as soon as we get a TCP packet, the script prints it out with all of the fields labeled by what they're called, and then it exits immediately so that I don't have that thing scrolling off the screen at high speed. And you see down here, flags is the name of the field that I care about. So now I can go back into my editor and say, aha, let me save that flags value. And then I'm going to do some tests on it in a little bit. And we're going to pull out and try to find out where these are. So flags is the name of the field. And I can put that in. I don't need these debugging statements anymore, so I can erase those. And now when I come in later and I need to look at TCP flags, I have that value saved. Okay. So I pulled out my fields of interest. I can do tests on those. I can say if both the fin and the reset field are both turned on, then that's illegal. I need to do something with that. And so I can do individual tasks while I'm looking at a packet, or I can summarize things like we did before and simply print out a summary when the script exits. Those are the two basic tasks. You can get a whole lot more complicated, but this is how you start. If you haven't already figured out, there are three ways you can enjoy this webcast. One is simply watch and get a sense of what's possible. You get you know after you've watched this webcast that there's some things you may be able to do, even if you're not interested in doing them right now. I'm glad you're here. The second is we're about to switch over into doing some sample code changes. And the nice thing is I think I've made it simple enough that everybody with Python 3 and Scapy installed should be able to follow along with the relatively straightforward changes we're going to make, and you'll be able to make changes to what this code does. Now, the final choice is, okay, Bill's done some interesting things, but I know a little bit about Python. Could I make my own changes? By all means, dive right in. Try out the examples that we're going to do today and go and extend them, make them better. That would be great. Okay. So how are you going to make these custom changes? Well, the nice part is all of the code is already in the script. What you're going to do is turn on or one of the code examples that you're interested in, and it's very straightforward. The first thing that you do is come up to the top of the script. I'm coming all the way to the top. I'm scrolling down to somewhere around line 30. No, actually, yeah, line 36. The current value for the variable code underscore example is protocol underscore count. And with that one turned on, that gave us the counts of each type of protocol. But I can change this. And I encourage you to do exactly this. Come up to this code, this block, comment out the first line that asks for protocol count, and instead uncomment the second line, which reads code underscore example equals 1 line per packet report. Okay. In your editor, save your changes. And now I'm going to exit my editor and I'm going to rerun the same command that I ran before, which is I'm going to run Python 3 sniffer template.py -r, meaning the next item on the command line is a PCAP file it should read from, and the name of the sample PCAP that we distributed with this webcast. Watch what happens. You don't get a summary at the end. Instead, you get here we go. Flying by on the screen at high speed, you have it 1 line per packet. What I'm going to do is see if I can widen this just a little bit, and we're going to try rerunning it, see if they'll go into 1 line per packet. It's possible they may not. No, it doesn't, but that's okay. What you get on each of these output lines is the protocol at the beginning, the source IP address, the source port, and now the packet is headed to 192.168.99.10 with a destination port of 63564. And here are the layers in that packet. We have Ethernet, IP, and UDP in that packet. So you get a very quick summary of what type of traffic it is. You get 1 line per output. And if this box were a little larger, they would actually fit on 1 line. What you're getting is a little bit of line wrap right now. So what did we just do? Well, we made 1 line change to the script and ran it. Oops, that was the wrong command. Here we go. We made a 1 line change to the script uncommenting the second code underscore example line, and now the script did something totally different. So let's say that you're looking at this and you're saying, well, that's nice, Bill, but how did you do that? What did you actually do in Python to change it to give you a one line per packet summary? And the way you find out is you search down with your editor for one line per packet. And I'm going to skip over that one. That's just a background piece of Python. And here is the interesting part. In between these red bars that I've temporarily put in, you see if code example is one line per packet report, then I'm going to construct a single line. I'm going to construct a variable called all layers. That was that right-hand block at the far right of the output that showed Ethernet, IP, UDP. I'm going to build that up, and I can build that up any way I want. You could replace this with something else that you want to see. And finally, down here, I actually use a print statement to print all of those out in nice, even columns. So at this block here is the formatting statement that says how wide each column should be. And then over here on the right, I have the protocol and the source IP and the source port. And then if you keep going over to right, we have destination IP and destination port and the all layers out variable that we just constructed. So I can pick any value that I want and set them out in nice even columns by using the format string. You can come along and use that same output variable, this particular command, with that format string, and you can modify it. Maybe you want to print something else. Maybe you'd like to show the Ethernet layer, the source and the destination MAC address. You can do that here. You can just modify this as a starting point and say, how could I make this print out the information I want to show? Okay. So I'm going to switch over now. Instead of that example, let's take a look at the next one. And the next code example is called show SSH clients and servers. So I'm going to come back to line 38, and I'm going to comment out line 37, which had the one line per packet report. And instead, I'm going to say, show me SSH clients and servers. Now, we're going to try something real quick here. The quirk is that this particular PCAP file, I don't think has any clients or SSH clients or servers. So in just a minute, we're going to find out, and I think I may have to switch over to a different packet capture file in order to do this. Okay. Okay. There weren't any in there, so I'm going to switch to something slightly different. And I'm going to read a slightly different PCAP file. Now, you can read off of an interface. You can read out of a PCAP file that has some SSH traffic, whatever works for you. But what I'm going to do for this example, I'm just going to read from one that has some SSH traffic in it. And in just a minute, we should see this traffic fly by. Now, you may have already realized that Python is not terribly fast at doing this. Python is not your first choice of a programming language if you need something to fly. It works fine, but it is not always the fastest language to do a particular task. And in this case, because we have so much traffic to read through, it's taking quite a while to move through all of the packets of the file. I'm going to show you how to solve that to a small degree. First of all, I don't care about all of the files in this directory. I'm sorry, all of the packets in these files. I want to look at traffic that I'm reasonably certain will be SSH. And because I know I have SSH traffic on ports 22 and 2222, I'm going to put in a filter that says I only want to see certain types of traffic. Is this going to work? Yeah, I think it will. Let's see here. This tells the operating system, hey, don't hand me everything. Just hand me, here we go. There we go. I picked the wrong sample packet file. If everything worked, it wouldn't be an actual demo. Okay, here we go. Yeah, exactly. You have it exactly right, grew the ood. Now, what I did was I pulled out a PCAP file that has actual SSH traffic. And here's how it differs from the last time. First of all, we have the protocol. We have the source IP, the source port, the destination IP, and the destination port, but we changed the last field. I pulled out the SSH banner string that the client presents to the server and the server presents back to the client, and I'm showing those instead. So I particularly care about this particular fingerprint. I want to see this as part of my output. Some tools will let you get to this, but certainly not all. And this is one of the advantages of being able to write your own sniffer. I can say this information is important to me. I want to show this information. Okay. So if we go back and take a look at the actual code that was involved here, let's search down for show SSH. And here is the block that's involved in showing you those SSH clients and servers. What I did was I said, I checked to see if the protocol is TCP, first of all, and I want to make sure that there is some kind of payload. And then once I have grabbed that payload, I say, did that payload start with SSH dash? And this literally is the way the SSH protocol works. Each side declares to the other what version it is so they know what languages to talk back and forth to each other. I grab the fingerprint by turning the payload into a string. And then I do the same thing I did above. I use a format string to say, show me the protocol. I'm going to scroll right here. I want to show the source IP, the source port, the destination IP, the destination port, and the fingerprint that side declared to the other. Does that make sense? That's how you get these one line per packet summaries with the information that matters to me in this case, or you on your own custom version of this script. Okay. What I'm going to do is skip the last two. They're much the same as we just did, and I would encourage you to take a look at uncomment ping payload and IP options as some more examples to try. But I want to switch back and just cover a little bit more so that we have some time left at the end for questions. Okay? Here we go. So that was the live demo time. Quick recap. Outside of what we worked with, we only looked at a very small portion of the script inside the process packet function. But outside of that was the code that parsed the command line options, that loaded up each individual PCAP file or opened the packets off of an interface. Scapy went through and parsed the headers of every packet, and then it handed that parsed object to process packet. At that point, you can take that work that Scapy did and pull out the individual values that care to you. You can do Python tests, you can do Python loops, you can save to a database, you can print to the screen, you could ring a little bell with a print command. You could send a note with syslog over to some SIM and have it record that a certain packet showed up with very odd characteristics. But most of the work that you care about is done inside process packet. The task of decompressing a gzip or bzip2 file is handled by the script. You don't even have to worry about that. You just worry about what do I care about and what do I want to show about those packets. We already talked about running p.show and sys.exit to print the parsed packet and then exit. So you see one packet on the screen. Once you know what the layer is, in this case, TCP, then you also know the name of the port, which is S port. Now you can assign the source port for that packet to a variable called, for example, TCP underscore source underscore port, and then do tests on that. What happens if that value is 0? What happens if that value is 65535? What if that value is foobar? Why would we have a string in a numerical field? A couple of tricks that'll help you work with this tool more quickly. Anytime you run this, you can add -H to the command line, and you will get a quick summary of what the command line options are. So if I run this instead with just -H, Python will tell me what the command line options are. You can ignore those warnings. It's a little quirk of how this system is set up, but this is the help output that matches the different options that are available to you. Now, if I want to read from an interface, I need to use my apologies. Sorry, Ryan. If I want to read from an interface, I'm going to use -I space and then the name of the interface. Because this is considered a privileged action, I have to be root in order to run this. So note that I need to have sudo in front of the command, and I'll have to enter my user password in order to be able to do that, just as with any other packet sniffer. If I'm reading from a file, I don't need to use sudo, because presumably I have permission to read from that file. If I know that the packets I care about are a certain type, do you remember how we used this form a moment ago? I'm going to bring this up. I'm going to make this window a little smaller so you can see it in the middle of your screen. At the end of this command, I said, hey, only hand me packets from that file that are TCP and have a port of 22 or 2222 as either source or destination. By telling the libpcap library on my computer that those are the only packets I care about, I'm not handed all 36,000 packets, whatever it was. I'm handed just the TCP packets that have those ports as either source or destination. That means this runs a whole lot faster. You are not asking Scapy to parse, 19,000 UDP packets that we don't care about, and the program runs a lot faster. Finally, if I only want to do a quick check with just a small number of packets, I can say, hey, let me go and see. I'm going to only look at the first 1,000 packets. And with a -C 1000 command line parameter, it just reads the first 1,000 and then says, do I have any interesting information in there? Turns out I don't have any SSH packets in the first 1,000, but I can limit it to just a quick test if I choose to. If this is interesting to you and you're thinking, well, could I try some of my own? Here are a couple of things that you could add to the script. The first is to change command line options so that you could feed in which code example you want to use rather than having to edit the script directly. Okay. The second is to send out an alert to a sysadmin when a particular type of traffic shows up. Okay. Third option is to remember the output lines that you've printed. And if you've already printed a line, don't print it again. So you get unique output. It means that a whole lot less lines will scroll up the screen. It'll be easier for the analyst to read. And finally, in the script, there's what I thought might be a fun one to work on at some point. It's kind of a, hey, show me all the packets that are interesting. So in this test right here, this 2-line test, I say if the source port is 7 and the destination port is 19, or if the source port is 19 and the destination port is 7, I'm going to set a variable called isInteresting to true. What is that traffic? Why would I care about it? Those ports for both TCP and UDP, although you almost always see it with UDP, are called echo and caregen. And if you generate a packet that has faked IP addresses and those 2 ports, you will start a packet that bounces back and forth between those machines until a packet gets dropped at very, very high speed. And if you just generate a couple hundred or a couple thousand of these between 2 computers on a network, you'll get them yelling back and forth to each other all day long. It's not considered a good way to run computers anymore. So that is just one example of what I would consider interesting. Now, you could come down to some of these other examples down here, and if you felt you wanted to see, do I see any of this traffic? By the way, most of these are generally things that you shouldn't see on a network. So by setting isInteresting equals true and then printing out the interesting packets or saving them to a PCAP file, this is one way that you could kind of look at the juicy stuff without having to focus on all the other traffic. All right. We're getting towards the end. I will come back to questions in just a minute. For more information about Scapy, these are the good starting points for that. GitHub has the actual source code. Scapy.net is the homepage for it, and the docs for it are at Read the Docs. The Sniffer template is a GitHub repository that we have up under the Active Countermeasures parent organization. You can pull down the entire repository. You can take, you obviously pull down the script so you can see how that works. If you want to just use this as an example, crank it right along. I've got a, Chris, question, please. Does Python still have to parse the lines to see if they match? Will piping through TCP dump be any quicker in a scenario? So I think what you're asking about is this example right here, where I said I would like to apply a BPF, or a Berkeley packet filter, of TCP port 22 or TCP port 2222 as a way to limit the packets that make it into Scapy and have to be processed. And your question was, hey, would it make sense instead to have TCP dump do that initial filtering and then hand the results off to a Python/Scapy script? And the answer is no, it wouldn't be any faster. And here's why. Neither TCP dump, nor Python with the Scapy library, nor any other sniffer in the world actually does the filtering inside the script. The libpcap library is the one that says, oh, hey, I've got this long list of packets, but I should only hand up the ones that are TCP and have a port of 22 or 2222. The library itself does that filtering. So what gets handed up to Python plus Scapy is already limited to just those packets, meaning that I don't need to go over to TCP dump, which is granted faster than Python plus Scapy. I don't have to get TCP dump to do the pre-filtering. You get the same number of packets either way. Okay? If that didn't answer your question, please go and bring it up again in Discord and see if I can get the right answer. If you'd like some more information about packet capture, we have some blogs on it, a ton of blogs on it. In particular, if you're having trouble capturing off of an interface, I would start off with the first blog, and then we have a category of blogs up on our website that cover packet capture in general. Almost done. I do want to thank Chris for introducing me in some ways to the basics of packet capture. Shelby and Keith helped set this up along with Deb and Jason. Aaron was on today helping out with pre-show and questions in Discord, and Ryan for doing the wonderful editing, which will hopefully get you a working copy in just a minute. And frankly, the guys who wrote Scapy. They have put in a lot of work to make this very easy for us. You don't want to have to go in and say, okay, in order to get this value from this header, I've got to go pull this out and multiply it by 4 and then right shift by 22. No, you don't want to do that. They've done all of the heavy lifting for you, making it much easier to do a custom sniffer like this. What else do we have for questions? Please come on up, and other pre-show people, come on and help me out with things that I haven't covered as we've gone through.
We're back.
Hey.
Hey there, Bill. That was great.
Hey, Bill.
Yeah.
Fantastic.
Yeah.
Did I miss any questions that would be worth covering?
Not that I'm aware.
No,
Yes,
I'm looking through it too, and I think people need to rewatch this about 4 times. So
Yeah.
There is a
Yeah.
certain difficulty in the fact that I've only got 60 minutes and there's a lot to cover.
Yeah, that's really great work, Bill. I mean, I love how easy it is to kind of customize exactly what you want to pull out of the data. It's
Yeah.
makes it very easy.
Apologies to anybody who isn't a Python programmer. It is Python still looks very odd if you haven't worked with the language. I'm not denying that statement at all. But if you got to a point where you needed some particular custom change to this script in order to pull out some field, I think you could probably find someone in your organization who's done a little bit of work with Python, who could take a look at the examples that we've already got in this script and then be able to make relatively straightforward changes to make this do what you want. So please don't get intimidated if Python is not your cup of tea. We totally understand, and nice part is it is possible to get some help to make these changes.
Bill,
C. Brenton underscore ACM, some person of ill repute, I'm sure, is asking what the title is on my business card. And that is Master of Shitty Little Shell Scripts. And I think I need to get a new business card that says Master of Shitty Little Python Scripts as well.
That can be the other side.
Okay,
flip
good.
side.
We'll flip it. There you go.
Yeah.
QR code on each side.
Yeah. Or just go, with the blanket statement, just all scripting.
Yeah, there you go. So I think we're basically finishing up. I think Ryan had mentioned, do you want to go and fill us in on the next phase?
Sure thing. All right, we're going to try something new for Active Countermeasures webcasts, but we've been doing it for a few times now, a bunch of times now on the Anti-Siphon webcast, if you've been to our Anti-Cast webcasts. And that is a breakout room where you, the audience people, can turn on your cameras, you can turn on your microphones. You don't have to, but you can, and you can talk to us directly and ask our wonderful experts here any questions you might have that's just burning your mind. Do you want answers now? Well, this is going to be your chance. We're going to try this. I'm going to open up the breakout room here, and then we're going to stop the webcast because we're pretty much done. That's it. So we're going to stop the live stream, stop the recording, but don't have to leave yet. If you want to remain on Zoom, jump into that breakout room and have a conversation with us. So
Fantastic.
That's what we're going to do next.
Thanks to everybody who
after,
took part of the main presentation. We appreciate it, and we'll see you on the next one.
Any other final words before we officially stop things?
We're all set. Thanks for your time.